So number 12 has an 4x to the 8th. So a pretty large power, which you notice a lot of the powers are pretty large. And then negative 61x to the 4th, and finally plus 225. So the first thing that you have to ask yourself, is there a GCF? Well, the 61 in the middle kind of ruins the GCF for us because we have a 4, and even that 225, like 225 isn't divisible by 4, 61 isn't divisible by 4. So no GCF that we can think about. The second question would be, how many terms are there? Well, there are 3 terms. So on that factoring flow chart, 3 terms is in the middle of the flow chart, and there's a couple of options. One option is to use AC grouping. Another option is to check if they're a perfect square trinomial. This one has the appearance of a perfect square trinomial because 4 is a perfect square and 225 is a perfect square. However, for this to be a perfect square trinomial, the middle number is supposed to be twice the square root of the first number and the last number. So if I took the square root of the first number and the square root of the last number and multiplied those together, I get 30. If I double that, I get 60. In the middle here is 61. So this middle number is supposed to be twice a times b for it to be a perfect square trinomial, and that middle number is not. So unfortunately, this problem does not fit a pattern, and instead we have to multiply a times c. So this is just a regular AC grouping problem. It's going to have a large number because 4 times 225 is 900. You will need a calculator to try and figure out factors of 900 because you're trying to pull 2 numbers together that multiply to be 61. So those 2 numbers are going to have to be pretty, that add together to be 61. So those 2 numbers are going to have to be pretty large in order for us to add them together. So yes, we could do 90 times 10, but 90 times 10 are too far spread apart because that would give me 100 or it give me negative 100, and those are too far spread apart from each other. Valeria, were you able to find a pair of numbers that multiply to be 900 but combine to be negative 61?
Yeah, I got negative 36 and negative 25.
And when you found that, did you just find that by like plugging numbers into the calculator, working through factors, dividing by 900?
Yeah, I just started entering numbers and then I kept going down because they kept getting closer to 61 together. So I just kept pressing buttons.
Okay, good. So he said he initially started just kind of entering numbers, and then you could see that those values were getting closer together. So when you put take 900 and divide it by 10 or divide it by 12, divide it by 15, look at those 2 answers that you get, those 2 factors. How close are they becoming to that negative 61? But try and have some type of systematic process so that you're at least like increasing your value that you're dividing by. So our 2 factors are negative 36 and negative 25, as Valerio said. And we're going to factor by grouping. So keeping, and I of course wrote x squared because it's just, I guess, ingrained in me that it's supposed to be x squared, but it's x to the 8th. And then negative 36 gets an x to the 4th because it's 61x to the 4th. And then negative 25 x to the 4th, and finally 225. So the second part of factoring by grouping is to group and pull out what they have in common. Zach, what would the first pair have in common with our 4x to the 8th minus 36x to the 4th?
4x to the 4th.
And what do you get when you pull out a 4x to the 4th?
You get x to the 4th minus 9.
Awesome. How about the next pair?
25, and then,
And
or negative 25, and then you get x to the fourth minus 9.
yeah, perfect. Nice. So the key concept that has to happen with factoring by grouping is that those two pairs must be the same. Make sure that you have a symbol in the middle of these pairs because this is still a quantity that is being added or subtracted. It's not total multiplication yet. So make sure you have some kind of symbol in the middle there, whether it's an addition or a subtraction. And that's dependent upon the symbol that would be in the middle of that 4-term expression above. So then we pull together our 4x squared and the negative 25. How about 4x to the fourth and negative 25? And we pull together x to the fourth and then minus 9. So then you got to ask yourself, is it completely factored? Can it be broken down any further? So Riley, is this completely factored, or can I take this and break it down further?
You can break down the 4x to the fourth minus 25.
And what does that become?
That would become x squared minus 5.
You are so close. What goes in front of that x squared?
2.
Yeah, so 2x squared minus 5, and then we would have 2x squared plus 5. So we have both of those. So one is a minus and one is a plus. That's the difference of two squares. Is there anything else we can do? Malachi, what else can we do?
X to the fourth minus 9 can turn into x squared minus 3 and x squared plus 3.
Nice job. That is also a difference of two squares. So both of those have a minus sign. It must be a difference. Both of them are perfect squares. That's why it's called the difference of two squares. So then if you look at your final answer that we have here, you still ask yourself, is it completely factored? And everything is still an x squared, but the other numbers are not perfect squares. So yes, it's an x squared, but 5 and 2 are not perfect squares. 3 is not a perfect square. So they must be perfect squares in order for us to factor it further. And in this case, they are not. So this is our final answer. You could have also checked the answer key and saw that you didn't have to factor it any further because the answer key said so. But I want you to understand why you can't factor it any further, not just because the answer key said so. So they are not perfect squares, therefore you cannot break it down any further. Questions? Are there any other questions that you wanted to ask? You can feel free to send it to me in the chat. All right, so I'd like you to go to Google Classroom. I want to show you the worksheet for today, and I want to start the worksheet for today with you. And then you're going to take a short 4-question factoring quiz. But before that quiz, I want to look at the worksheet. So in Google Classroom, the worksheet is posted. It should be the first thing if you just use the stream. It's also under classwork, but it's that 5-1, 5-3, 5-4. Remember, we skipped over 5-2 because 5-2 is graphing, and we're going to graph the two sections together. So pull up that worksheet. This is a review worksheet of the concepts that we discussed prior to Christmas and then the factoring concepts that we discussed this week to kind of pull everything together. So you can see the first questions up here are a review of scientific notation. When you're looking at scientific notation, in example number 1, you're going to multiply the numbers together, and then remember you add the exponents. So my answer would be times 10 to the 11th. And then I'm multiplying 3.4 times 2.8. When you look at your solution, make sure that it is in scientific notation. That first number is supposed to be from 1 up until 10, but not including 10. So multiply and then just make sure you're in scientific notation. 4 through 7 are exponents. It says tell which properties you used. Make sure you're just kind of understanding those properties that you are using in order to simplify. And then the group at the bottom here, these groups of problems are section 5.3, adding, subtracting, and multiplying the polynomials. On the next page, we have some factoring problems, just like we've been working on. And then 26 and 27 want you to find the real number solutions. This means to solve. So when it says find the real number solutions, your answers are not supposed to be imaginary. They're supposed to be real numbers. So you shouldn't have an imaginary number as a solution, but you do want to solve for the variable. So that's what find the real number solutions means. It means to solve. I wanted to start number 28 with you so that you could have like a head start on the word problem to kind of think about what to do with this problem. We did one like this yesterday. We were in a park and there was a fountain in the park that we did yesterday. And this one is a flower planter. So you're designing a marble planter for a city park. You want the length of the planter to be 6 times the height and the width to be 3 times the height. The sides should be 1 foot thick. Because the planter will be on the sidewalk, it does not need a bottom. What should the outer dimensions of the planter be if it is to hold 4 cubic feet of dirt? So we have this planter. And the planter is going to have a space in the center of it for us to put dirt and flowers. I mean, that would be the goal. So a space in the center for us to put dirt and flowers. So inside here is going to be our wonderful flower display. You want the length of the planter to be 6 times the height and the width to be 3 times the height. So the height is just X because everything is based off of the height. It says the length is 6 times the height. So my length would be 6X. The width is 3 times the height, so the width is 3X. So whatever they're kind of comparing it to, that's your variable. Comparing it to the height means the height is just X. Everything else is a multiple of that variable. We also know that the sides should be 1 foot thick. So we have a foot here, a foot on each side. But it doesn't have a bottom because we're not putting water in this. I mean, yes, we're watering the dirt, but we're putting dirt in it. And if it sits on the bottom, if it sits on the ground, the dirt isn't going to spill out. So it doesn't have a bottom. The last part says we want to know what the dimensions would be if it's going to hold 4 cubic feet of dirt. So when we're talking about holding an amount of dirt, that's our volume formula that we used yesterday, length times width times height. And the volume is 4. So thinking about the fact that the dirt is going inside, and we have to find the volume or the space that is representing. And that the sides of this planter are 1 foot, but it doesn't have a bottom. Faith, do you think you could write an equation to represent our diagram and the information that is drawn?
Yeah, I think so.
So what could we write for the length?
For the length, it would be 6 feet or 6x.
Okay, so 6x. And then what are you subtracting from that length because of the sides of the planter?
Would you subtract 2x or 2?
Yep, just 2. Good. So that's the length. Do you think you could do the width?
Yeah. Would it be 3x minus 2?
Mm-hmm. And again, we have to subtract 2 because each side is 1 foot. And then finally, what's the height, Faith?
X.
Yeah, and it's just x because we're not subtracting anything. The height of this goes all the way to the bottom and it's sitting on the sidewalk. It doesn't have a 1-inch thick base. So that's why the height is just the value of x. Any questions with writing that? Nice job, Faith. So Brooke, we're not going to solve this together, but could you explain the next step that you would use to solve this problem?
I would either like multiply the two binomials, or I would like distribute the x, either one.
Perfect. A nice word. Nice job using those terms. So she said she would either multiply the two binomials together and then distribute the x, or you could distribute the x to the parenthesis it's sitting next to and then multiply them together. It's your choice, whichever you want to do. Brooke, after you do that multiplying, then what do you have to do next?
You would combine them. Well, yeah, you would combine them and then subtract that 4 over.
Yeah.
So it's equal to 0, so you can get the answer.
Very good. So you have to subtract the 4. You're going to combine all your like terms. This is going to be equal to 0. The zero product property. When you're factoring, your factors must be equal to 0 in order to solve for x. So you're going to FOIL, multiply together, set it equal to 0, and then use my favorite F words besides FOIL. I mean, FOIL and factor and fun. Those 3 F words should go together every day. So you're going to FOIL, you're going to do some factoring, and you're going to have some fun solving number 28. Don't you all wish you could be in front of me in the classroom right now, laughing your head off because your teacher is so crazy? Next week, you'll be here, and then you can remind me how crazy I am. All right, so I would like you to work on the rest of this worksheet. This is your homework. Tomorrow, we're going to do graphing. But right now, I actually want you to go back to Google Classroom, and let's hope it's there. See if it posted yet. Nope, didn't post yet. So I will open this for you. So there is a 4-question factoring quiz on Google Classroom. It should be open for you now. I'm going to pull it up so you can see what it looks like. I'll keep it on my screen. If you could please do this 4-question factoring quiz while you're still on Zoom with me. When you are done, you may leave or you can stay and ask questions about the homework, about the review worksheet, totally up to you. But I want you to work on this 4-question factoring quiz, submit it to Google Classroom. You are allowed to leave after it's submitted, or again, you can stay and ask other questions.